What's up people? Sam here. If you've ever worked with breadboards before, then you know that you have a few very major limitations to them. Those limitations are 1. Timing, and 2. Storing data. Both of them are technically possible, but they are very hard to do. Like this breadboard here is using an accumulator timer, but this video isn't about that. It's about how to avoid using that with a new creation of my own that I name ACB computers. Now, if I say computer, I'm not talking about the computer that I'm playing on this game right now. This is much closer to what they used in World War II when they're targeting computers or artillery calculation computers with a lot of moving parts, really mechanical computers doing the math with switches and all that stuff, which in my opinion is even more amazing because there's something deeply fascinating about mechanical computers and just watching moving parts move, which is also what I love about the ACB computers, really. But enough talking, let's show some examples, shall we? Now, before we get to the really complicated stuff, let's start with something a little bit more simpler. Helios, you already know the drill by now. It has this awesome combat mode. Like, this is passive mode, and if I press this complex control, I go into combat mode. Building this obviously meant a lot of back and forth, turning on and off the combat mode, and that almost always involved me holding down a key on my keyboard while building in order to activate the complex control. Very annoying. My first solution was to use object detection on this ACB, which when there is a block placed here would permanently activate combat mode. However, once again, this needed a lot of back and forth, because every time I wanted to turn it on or off to see if the gates would fit properly, I would have to go out of build mode, move over here, go back into build mode, remove the block, yada yada yada, a lot of work. Oh, how I wish if there was an option to just press one button and then permanently turn on combat mode, and then press the same button again to permanently turn it off again. Which is what this system right here is. Just ignore all of the rest. The ACBs are of different use. All I'm talking about is what is within this area right here. Okay, how does it work? The two on the bottom basically just say, if I press the complex control U and there is an object right in front of this control block, it will set this spin block to the position it's in right now, and over here it's pretty much the opposite thing. Also, if I press U, it will set the spin block to the opposite position. So if I now press U, it will move it over, and if I press U again, it will move it back. And for every time I press the button, it will move back and forth and back and forth and back and forth, etc. And this guy up here is my good old trusty, if there is an object within range, it will activate the complex control O, which, like I said, is the trigger for the combat mode. So now combat mode is activated, and now I move this block away, so now combat mode is off. So if I'm over here in build mode on the craft itself, I can just press U, and now I'm in combat mode. And I can press U again, and now I'm out of combat mode again. And it doesn't interrupt my work. Now right here I'm using the same complex control, the complex control U, to switch it back and forth between the two states. However, I could in theory also have two ACBs. They don't even have to be next to it. That's just listen to different complex controls and set it to an absolute value. So if complex control U is pressed, then go to 0 degrees. If complex control L is pressed, go to 180 degrees, and basically remove the whole bottom layer and just go for that's the input layer, and just go for the output layer, the top one here, that does the and just go for the top layer here that does the detection and does the output, which is basically having an absolute input. If this key is pressed, set the spin block to this value, and then you have a relative input, which means if a key is pressed, then go to the next step, go to the next value in the circle. And if that sounds familiar to you, then congratulations, you've just discovered the difference between a button and a switch. That's pretty much the second thing I learned in electrician school right after don't lick the cables, electricity isn't that tasty. Now, there's absolutely nothing stopping me from adding more nodes. Like, I mean, I could build one here and another one here. Okay, so what uses this now to us? Well, it stores data. So if you have a plane that flies a complex attack pattern where it's dodging and whatever, it can always remember in what step of this attack pattern it is right now, just as an example. The beauty here is that right now, obviously, every time I press T, it moves by one step. But it doesn't have to be. I can have as many external ACBs around there that just set the spin block to a fixed value, so you can skip steps and move directly to something else. So if your plane is getting shot at, you immediately move to evasive maneuvers without stepping through all of your usual routine first. What we are looking here is the lap counter for the racetrack that I built for the tournament. The idea is every time a car drives through this gate, it gets detected by these ACBs, and that sends a complex control, and that jumps to the next lap, to the next step. Like this, for example, I can trigger them manually as well. And you move to the next lap, and you move to the next lap, and then when it's finished, the clock stops where it was. And if you press T once again, it resets the whole track. It resets the lap counter so that you can start over again. Okay, but let's say I crashed at lap 2, I respawn my car. I don't want to have to drive through the lap 2 times more, so instead I can just reset, which is an absolute input, meaning it will rotate the spin block back to its original position without having to go through all of the complexity of going through the cycle. Right? So you have differential inputs, which is go to the next step in the cycle, and then you have absolute inputs, which say go to this specific position. And how to build them is, well, the differential inputs I already told you. It's if there is an object within, so they all listen to the same complex control, T, 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 and T. And if this complex control is triggered, only the one with the sub-object in front of it, the hand of the clock, will get triggered and move it to the coordinates that I gave it. So all of those have different coordinates. This one is sitting to 90 degrees, this one 135, 180, etc. So only this block gets now triggered, and it will move it, the spin block, in this direction. And now this is the one that gets triggered, and it will move it over here, and so on. Whereas this ACB right here is set to always rotate the spin block to 0.0 degrees, no matter what. So if I trigger it, it will move it to the reset position. That's what the lower layers of ACB does. The top layer of ACB is basically the read part. You can basically say this, the guys on the bottom are the write part, because they receive inputs from the outside world and feed it into the spin block and move the spin block around. The top layer is the read part, and they basically detect is the spin block at our current position, and if it is, it will do actions like put the lap counter to 1, put the lap counter to 2, put the lap counter to 3, stop the clock entirely, or reset the clock. That's how these things work. Now there is a little issue here that I didn't consider back when I built this racetrack, but that can actually also be solved with ACB computers, and that is time delay between two cars passing. You see, if I hold down the complex control T that makes this computer work, yeah, you don't want that happening, right? I think you can tell why. So how do we avoid this? that a car that's like 10 meters long and spends 1 second until the entire car has passed through the gate, how do we stop it from triggering the lap counter multiple times? Well, you have a control block right here that is slotted in between the two, and basically just translate from one complex control to the next. So it takes the complex control that these ACBs give, which is the key right, and translates it to the key T, and T is the one that gets used down here, and it's listening to a minimum activation delay down here. So if I press right, I can now press right as often as I want. Nothing happens because this guy is still on cooldown, and only after the 10 seconds have passed I can press the right again or drive my car through the gate again so that it activates. This system, however, has two problems. One of them you already saw. If I made a car that is so insanely fast that I can make a lap with less than 10 seconds, then it wouldn't count, it wouldn't consider, because this ACB is still on cooldown, even though I made another lap. Simultaneously, if I set this activation interval too low to compensate for that, if I press right and keep on the right key, I have not yet passed the entire car through the gate, and I'm still skipping through all of the settings. Which means that this slotting in an ACB to create a delay in between works in most cases, but it's not perfect. So how about we build an ACB computer to compensate for that? And we have a finished system. This guy is the input. If right is pressed, we'll rotate spin block 280 degrees. Currently it's in 0. And this guy will basically just move it back. And this is our output block, which as soon as the block passes in front of it, it will send the output signal. So if we look at here, right now it's 0, left 0. If we press right, it was a bit fast, but I can slow down time for you if you want. If we look at it really close, as soon as we press right, we move in front of this ACB, which then triggers for just a fraction of a second, only for the time while the wood block passes in front of it, and now it's locked in the 180-degree position. And as soon as I let go of the right key, it resets to the last position, so that the next time I press the right key again, it can trigger it once again. And this is basically a rising edge trigger, which means only when I start pressing the right key will it trigger, not when I let go of it, and the timing delay between the two is completely independent, as you can tell. It works brilliantly, even though the spazzing out is a bit weird. I'm sure there's a more elegant way to do this, but I want to just throw out the general concept out to the public, to the community, so the community can start working on it, improving on it, because I personally don't want to shoulder the whole project on my own. This whole thing isn't supposed to be an idea that replaces Breadboard or works against it or is concurrent to Breadboard. No, that's not what I'm saying here. Breadboards are awesome, they have their limits, but they are awesome and stay awesome and will always be. But it's a complementary system. Breadboard has its limits, so do ACB computers. ACB computers are awful in many ways, but both together can make life quite a bit easier for an amateur builder like myself. The difference is that Breadboard works kind of analog, meaning that you can have a single variable can have a ton of values, while ACBs are more like digital, so you only have on and off, high or low. Nothing really in between. However, the ACBs give you the options of setting timing right down here with effect delay and activation intervals. You can store data by saving the position of the spin box, etc. What system works best is really dependent on the situation. There's no best system, period. And I just wanted to make the community aware that this is an option. This works amazingly enough, and there's a bunch of users for it, and I'm really curious to see what the community can build out of these things now that they're out there. Anyways, that's it for me. I'm certain that this technology will find use in my future projects, such as this one, the water strider, which will hopefully eventually be able to fold its legs into one side and then jump like you've just seen, except, you know, balanced and better. But that's just, you know, plans for future projects. I'm certainly not running low on ideas, I'm more running low on time to actually make them and also make videos about it, documenting them. I hope you enjoyed this one. More of a technical one, less showing off something flashy, something spectacular, something explosive, more technology. But I still hope you enjoyed it and maybe you learned something. Maybe you will also try to implement this in your own projects. Have a nice weekend and goodbye.